Now, after we have identified or predicted the number of intersections our parabolic graph will have for each of the equations here against the x-axis, let us try to verify if these predictions are true by graphing it in the Cartesian plane. Now, this is only concerned with this prediction, but you could also make predictions as in relation to the previous uh, analysis, like it involves shapes, concavity, and location of the vertex, but it's no longer the concern here. So our task for now is to graph. Take note that when before we could graph this, we need a table of value, and whatever points we have there, we are going to plot it here in this Cartesian plane, and to verify later on if we have really made correct predictions as to the number of intersections. Don't forget that when you graph, you're always expected to start with the vertex, which is comprised of f of x and its corresponding f of x, or in other sense, y. To solve for the vertex, we're already given with the formula for x, which is negative b over 2a. We already have our coefficients here. When you substitute that, we'll have the negative of negative 4 all over 2 times 2, which are both the values of b and a. If we move further using a double negative property, you will have 4 for your numerator and 4 for the denominator, which will give you a value equal to 1. This is the value of the x coordinate of your vertex. If you have noticed, this is not the same as the previous quadratic functions that we have graphed, since the vertex or the x coordinate of the vertex always is at 0. Right now, we are expecting a graph or a vertex of the graph no longer be located at the origin. To complete that, we are going to substitute the same value of x, which is equal to 1, to the given equation properly. Our equation is 2x squared minus 4x. So you have 2 times 1 squared minus 4 times 1. The value for this, you have 2 times 1 minus 4. And the pair or the value should be, for y or fx, should be negative 2. Pairing the two coordinates, you will have the vertex located at 1, negative 2. This is the vertex of your quadratic function. This value shall be placed here in the middle. Here, let me just use the red text, or I mean red colored text, so to make it similar with the previous graphing, and place the values here of 1 and negative 2 in the middle. And here we will decide the next integers above and below the x coordinate. It will include the points or the x for 2 and 3. In here would be 0, negative 1. To determine the remaining coordinates or points, we are going to substitute them one by one on our given function here. Let's start with 2 equal to 2, 2 squared, using the same given, minus 4 times 2, which gives us the value of 2 times 4 minus 8, which is actually 0. So the first point after the vertex is the point of 2 and 0. Let me add 0 here, and we are down to the remaining 3 coordinates. Next is f of 3. Using the same given, you have 2 times 3 squared minus 4 times 3. This is 2 times 9 minus 12. 18 minus 12 will give you 6. So the next point is given to us by 3 and 6. So I'm going to add here 6. We already have some analysis as well that if we are going to substitute our values properly, we will get the same values as here, and the same value for this area as well. So we are expecting this to be 0, and this is also 6 per trend on our previous analysis. But let us go further with the correct substitution. F of 0 is equal to 2 times 0 squared minus 4 times 0, okay, which will give you both zeros. And then the next coordinate is 0, 0. This is the origin of the Cartesian plane. Hence, it will still pass through that, but the vertex is no longer at 0, 0. See, we have the same values here and here. To complete, we have f of negative 1, which will need proper substitution and evaluation. 4 times negative 1. When you take a square of a negative number, it becomes positive. And when you look at the other side, negative times negative becomes plus 4, which will give you a result of 6. So same here, 6. The last point is at negative 1 and then 6. So using this table of values, we need to show our graph in this Cartesian plane and probably tell later if it's really correct that there are two intersections with the x-axis using the concept of the discriminant. So let me add it here. And since our vertex is no longer at the origin, let me add here this x-axis somewhere here and somewhere probably here for our, just like that. So let's plot the points of our graph rather, in the Cartesian plane. Our vertex is at 0, 1 and negative 2. So here at the bottom. So this is your vertex, right? Our next points are at 0, 0, and 2, 0. And finally, you have 3, 1, 2, 3, 6. 1, 2, 3, 4, 5, 6. And then the other side, negative 1, 1, 2, 3, 4, 5, 6. Okay? And when we connect this, pardon my drawing or my graph, it should form a U shape for a parabola. Sorry for that. Just like that. Okay. Let me erase these portions here. So your graph will somehow look like this. And please do not forget to include arrowheads as this pertains to moving further towards infinity. Now, let's find out if our prediction earlier about two intersections with the x-axis is correct. Take note, this is your x-axis. So we have 1 and 2 intersections here and here. So looking at the given, you have two intersections. It meets the criteria using the discriminant. So it's really correct that there are two intersections just by using the value of the discriminant, even without graph. Above all, you could even add other analysis or predictions we had earlier or in the previous video. Take note that the A coefficient determines the shape and the concavity. This is 2. That's why the graph is narrower than the normal. Second, this is positive 2. So it is opening upward, not downward. But for this specific exercise is concerned, only focus on number of intersections, we have met the standard. Let us proceed to number 2 and determine if the graph of this will not intersect the x-axis, as the value of the discriminant is negative. Still, we start with our vertex, which is given as negative b over 2a. Okay. Our b is negative 6, so we'll have the negative of negative 6 is negative over 2 times 1. This will give you a value of positive 6 over 2 and will give you 3 for your x coordinate of your vertex. Substituting that to come up with our correct vertex to the given, this is trinomial, so you need to be careful with substitution. Always use parentheses if it's possible. Minus 6 times 3 plus 10. 3 squared is 9 minus 18 here and plus 10. That's 19 minus 18. You will get a value of 1. So the vertex is located at 3 and 1. So we are going to place this at the middle of our table of values and determine the next coordinates using that. So you have 3 and 1. That's your vertex. And we pick these values above and below. Okay. So same thing as earlier. Let's substitute them one by one. Let's start with f of 4. And the given, this should be 4 squared. A little bit lower. Sorry. 4 squared minus 6 times 4 plus 10. 4 squared is known to be 16. This is 24. And this is 10. 26 minus 24, you will get a result of 2. And hence the next point is at 4 and 2. I'm going to place here 2. If we are going to continue with that side, f of 5, you will get this expression. 5 squared minus 6 times 5 plus 10. 5 squared is 25 minus 30 plus 10. That's 35 minus 30. You will get 5, and hence your second point, other than the vertex, is 5 and then 5. So you will have here 5 and 5. Same as earlier, we are expecting this to be 2 and this is 5 for it to be a pattern. Let's further clarify it. F of 2. So you will have 2 squared, parenthesis, minus 6 times 2 plus 10. 2 squared is 4 minus 12 plus 10. So you will have 14 minus 12, you will get 2. So it's correct to assume 2. And your point is really 2 and 2. Okay. Now for the last rather, f of 1, we are expecting a result of 1 squared minus 6 times, that's 6 times 1, sorry. 6 times 1 plus 10. So you will get a value of 1 minus 6 plus 10. 11 minus 6 is 5. It's correct that the last point is 1 and 5. So these are your points here. And since I could not see it, same as unlike earlier, let me copy this portion and add here at the bottom just to make verification later. So we are expecting no intersections with the x-axis. So since there are no intersection, let me place the x-axis a little bit lower. We are assuming that it will not intersect this. And since the largest or the values are greater than 1, let me place 0 here or the y-axis. So let's plot the points using the vertex at the 3, 1, 2, 3, and then 1. This is your vertex. The next point is at 2 and 2. You also have 4 and 2. So looking at these 3 points, you would see that it will just open upward, which is still supported by the value of a here is that is greater than 1. Our parabola will open upward and it will never intersect the x-axis. If we are to continue, 1, 1, 2, 3, 4, 5. You have here 1 and 5. You also have here 1, 2, 3, 4, 5, and 5. So connecting this, sorry, you can see it does not intersect with the x-axis, but still it produces a parabolic graph. So none, correct. It doesn't intersect the x-axis using the value of discriminant. Okay, let's have the last item, number 3, here. And we have shown that there is only one intersection with the x-axis. Let us verify that, starting with the computation of the vertex, which is negative b over 2a. Your b is already negative 2, so please make sure to substitute the signs properly. You have 2 times 1. So negative of negative 2 using double negative property, that's 2 over 2. You will have 1 for the x coordinate. Using that value, f of 1 of the given equation, which is x squared minus 2x plus 1, you will have 1 squared minus 2 times 1 plus 1. So you have 1 squared is 1. You will have here minus 2 plus 1. That will give you 0. So the vertex is at 1 and then 0. This is the vertex of our parabolic graph at 1 and 0. So let's place it here. You have 1 and 0, and you decide the next few points, which will involve 2, 3, 0 here, and negative 1. And then slowly solve each step of the way. You have f of 2 using this given function. You have 2 squared minus 2 times 2 plus 1. 2 squared is 4 minus 4 plus 1. So you will get a value of 1. Your first point after the vertex is at 2 and 1 here. Let's try to change this process a little bit. Instead of moving to 3, let us go to 0. That should come up with the same value of 1. So if we have f of 0, so it should be 0 squared minus 2 times 0 plus 1. 0 squared is 0. This is also 0 plus 1. See, it's still equal to 1. So the point is 0 and 1 here. We're just changing it a little bit because it doesn't necessarily mean that you always start with that. You could start any of the 4. So let's go to f of 3. Okay, that's 3 squared. 2 times x, or I mean negative 2 times x, so negative 2 times 3 plus 1. 3 squared is 9 minus 6 plus 1. So if you're going to combine that, you will get 4. So the remaining point should be, not remaining, yes, remaining on one side is 3 and that's 4, sorry. 3 and 4. So it should be 4 here. So we are also hoping for this. Let's verify it further. F of negative 1, be careful with the sign, negative 1 squared minus 2 times negative 1. Please consider always the given. And then you have here plus 1. Negative 1 squared is positive 1. We have negative 2, negative 1, plus 2. And you have here plus 1, which still gives you 4. So the last point is at negative 1 and 4. So this now completes this, our table of values. And to verify whether the graph really would have one intersection with the x-axis, let's place it here and make it a bit smaller. Okay, so we are verifying this. If this is correct, if this is not, then probably we could not accept the analysis we made earlier. So there should be only one intersection with the x-axis. So let me place here the x-axis somewhere here. For a while. And the other would be here. So let's plot the points. Let's start with the vertex. Oh, sorry, that's black. And let's start with the vertex. The vertex is at 1 and then 0. To be followed with 0 and then 1. And we have 2 and 1. Finally, you have 3 and 4. 1, 2, 3, 4. And you also have negative 1 and then 4. Let's connect this. This is my graph. All right. Okay. Extend towards infinity. Notice that this graph only intersects the x-axis at this point. This area here, though it intersects this axis, but this is just y-axis. So it's not counted. So it's really correct. There's only one intersection. So for you to be able to add some assurance onto you what your graph will look like, you could also check using discriminant and determine whether how many, or I mean, determine the number of intersections your parabolic graph will have against the x-axis. So just by checking the discriminant and deciding the number of intersections, and then later on graph, if it will not meet or if they are not equivalent to what is predicted, then probably there's something wrong with your solution or your processes. Now, let us try to verify this further using Desmos. I shared to you Desmos in the previous video. Let's have Desmos again here. So this is Desmos, and let us try to input our functions here, and will it really and it will help us rather determine whether our graph is really correct and the number of intersections will also be correct. So for number one, we have this function. Look like this. So you have your function f of x is equal to, you have your keypad here. You have 2x squared minus 4x. This is the graph. In our prediction, we only have two intersections. Okay, so we have two intersections here at 0, 0, and 2, 0, just like our graph earlier. Here, this is our graph. Okay, 0, 0, and 2, 0. Okay, that's for our graph. And the vertex is at negative 1. I mean, 1 and negative 2. It's same here, 1 and negative 2. If I'm going to add the next functions to also verify them, so for the second function, f of x is equal to x squared minus 6x plus 10. Okay, look at the blue graph here. It does not pass nor intersect at the x-axis. So same as our prediction, no intersection, and the graph is similar to this, more or less. Okay, more or less similar to that, the blue one. Our vertex is here at 3, 1 and 3, 1. Okay. This is our vertex at 3 and then 1. And finally, for our last function, we have x squared plus 2x plus 1, where we predicted, and we have shown here to only have one intersection with the x-axis. Using Desmos, you have f of x is equal to x squared minus 2x plus 1. Look at the green graph. This one here, it intersects the x-axis at only one point. That's 1, 0. Similar here, 1, 0, which is also our vertex. And even if it will intersect the y-axis, it's not counted as the concern. So this is the graph. So these are our graph, the three graphs of our given three functions. Okay. Desmos is just used to verify whether our graph will match with the correct one. And take a look at the graph. It opens towards infinity. Not necessarily the same as these graphs of ours, but we have a portion of it. So this is for our second practice exercise on lesson number 2, which is graphing, using the predictions on number of intersections through the value of the discriminant.